Yes. So. Yes.
Okay, so until you bring it back, like you had the results you got from this figure that the bacteria with the BRK positive utilize less zygote, right? And you interpreted this that it's using another source of carbon.
Yes.
Like, what if the bacteria that is BRK positive is metabolically less active than the control bacteria? That's why they are not using like the same amount of carbon as the control one, because they are maybe like intoxicated with your like product or BRK or whatever. Like how you interpreted the decrease in consumption of the zygote into a decrease of consuming carbon.
Thanks for the question. So, in the definition of the XUI is that by growing up to 1 unit of biomass, we calculate that the bacteria strain should consume how much xylose. So, in our median, there are only 2 carbon sources for the bacteria. So, to grow up to 1 unit of the biomass, it requires a carbon source from either xylose or carbon dioxide. So if it consumes carbon dioxide, it requires to consume less xylose than the wild-type engineered strain. Yes.
Like my question was, maybe the bacteria is not growing. That's why it's consuming less carbon.
So in this, we made 2 assumptions for the XUI. First assumption is that the OD600 has linear relationship with the biomass, and the second one is that the carbon percentage in the biomass is fixed. So by this, we can calculate, we can indirectly say that the carbon from the biomass can be equivalent to the OD600.
Okay, thank you.
Thank you for the presentation. It was really great. I'm curious about the collaborations that you had, specifically, I guess, with the China Steel.
Yes.
Just to understand a little bit more, I want to kind of understand the story of where they came into the picture in your development and how their feedback fed back into your project.
Okay, I would like to invite Jenny to talk about our experiments.
And thanks for questioning. Your question is about our visit of China Steel Corporation. And actually, the China Steel Corporation is the largest steel maker in Taiwan, so they will make some carbon emission problem. So we think that our E. coli carbon utilization system, maybe they will be willing to use that. So the first meeting we proposed the whole flow chart, or what we mentioned in the slides. And actually, for this slide, we just want to build a bioreactor system that can utilize carbon dioxide. But after a meeting with them, the first question from them is about the E. coli adaptability. They think that the condition in the industrial may not like the lab. So for this question, we answered about maybe the fixation rate not that better, not like that good in the lab, but it still can fix carbon. And another part is is a valuable product. The China Steel Corporation thinks that if we can not just fix carbon, can also convert carbon into the commercial product. So after the meeting, we plan to design. We think that it is possible to design other pathway E. coli which can convert carbon dioxide into the commercial product.
So I guess, at what point in your project did you present this flow chart to them? Was this in the beginning or more towards the end of your project?
In the beginning, they were just like this flow chart, but not that complete. So it's the complete flow chart after the meeting.
And the valuable byproduct, what did you do with that feedback that they gave you? Have you incorporated that into your project at all? At this point, have you incorporated that into your project?
Actually, we haven't collaborated with it, but we believe in our future plan we can collaborate the pathway with our project. Yes.
Okay.
Thanks for the question.
Thank you.
So.
All right, it looks like we're at time, so thank you again. Let's have a round of applause.